And now you can see the recording. Yeah. Hi everyone. Nice to see you all here for our second workshop. And we are doing this workshop in collaborating with AWS, Amazon. It is the second one. Before this, we had introduction to AI and machine learning, and also next month in October we have the workshop, and this topic of this workshop is large language models and generative AI. Here you see this QR code. You can scan it. It is Eventbrite collection for all workshops. For example, if you don't register for the next one or for the last one, you have chance. We have maybe few spots now available. And my name is, I forgot to present myself. My name is Anna Silvanen, and I am from Women in AI Finland. Here we can see the topic of our workshop. We will go through MLOPs best practice with AWS, and also our second speaker will talk about use cases in health AI solutions. And here is our speakers. So the first one is AWS Solution Architect. She was seen. Yeah, she's now telling. And then Sophie Wari. She's a co-founder at Velmia and also AI researcher at Aalto University, and also part of our core team in Women in AI. She's our partnership lead. And here we can see our agenda for this day. So at first we have two presentations, and then I think we have time for 5-minute break. And after that, it will be labs. And if we have time, also 10 minutes we have for conclusion and feedback. And now about practicalities. So please, during the main presentation, use Q&A section. It is in your Zoom window, in Zoom panel. And if you don't see it, you can click these 3 dots and you see it. So type your question in the QR box, and then some of our experts will answer there. I wrote also links there for labs and for one challenge. I will talk about it a bit later. But after a break, we have labs, and we have only 2 breakout rooms and don't have a main room at all. So please choose your room. The first room will be beginners. I will open it later. And the second one will be advanced, and it will be recorded. If you want to ask questions there in breakout rooms, please use this chat or unmute yourself. And the last thing what I was to promote, we promoted this also in our first workshop. AWS got a challenge, so you can scan it or go through the link in QR session, and then you have a 50% discount on your AWS certification exam. I think it is all from my side and practicalities, but if you have any question, please type in Q&A session. Of course, you also can use this chat, but when people writing a lot, maybe we don't notice very fast this question, and it is better to use this Q&A session. And I think my presentation, I can stop, present, sharing, and share. Stage is yours.
Thank you, Anna. Hi, everyone. I hope you can hear me. Now I'm starting sharing my screen. See. I hope you can see my screen now, everyone.
Yeah.
Hi, everyone, and welcome. My name is Xiaoyi Xin, and I am a solutions architect from AWS. Today, I will walk you through on how to implement MLOps practice on AWS. We will talk about what is MLOps, why MLOps, why it's important to us, how to mature on MLOps in terms of people and processes, and how to mature on MLOps in terms of technology. And last but not least, how you can get started. So when we want to productionize the machine learning solution, ML code, the machine learning code that the data scientist is used to produce is very tiny piece from the bigger picture. So back to 2015, refer to the paper Hidden Technical Debate in Machine Learning System. It mentioned that only a small fraction of real-world machine learning system is composed of the machine learning code. This is not new, but it is still valid to create many different configuration mechanisms, automations, data ingestions, monitoring mechanisms around the machine learning code to make sure that when we move to the production, it is secure and robust. So what is MLOps, so to say, ML operation? A key challenge is that our customers used to have many different teams of personas, such as data scientists, machine learning engineers, data engineers, business stakeholders, and they follow completely different KPIs and processes. And they need to use completely different services. So the key question becomes, how can we combine people processing technologies in order to productionize machine learning solutions efficiently? This is where MLOps can help. So MLOps is a set of operational practice to automate and standardize the model lifecycle, including building, training, deployment, monitoring, manage, and governance. It can help companies streamline the end-to-end machine learning lifecycle and boost productivity of data scientists and MLOps teams while maintaining the high model accuracy and enhance security and compliance. So MLOps is similar like DevOps. It is more than just a set of technology or services. You need the right person with the right skills following the same standardized processes to successfully operate machine learning at scale. The technology exists to facilitate those processes and make the job easier for the people. Therefore, those three pillars, people, technology, and processes need to be collaborate together. MLOps is a difficult topic because it requires a combination of multiple domains. For example, we need to combine machine learning with DevOps, with data engineering all together. So why MLOps is important for you? The key benefit of MLOps is to standardize operations and infrastructure for your data scientist. This is a busy slide, but let's focus on the column on the right. First, it improved the speed to value from 12 months to 3 months. Second, if you have already implemented some of the machine learning use case and ready to productionize, it will move from previously 3 to 6 months to less than 2 weeks by reusing many existing components. Third, in order to reuse those components, we do templatization. We reuse as much as possible of your code that created. It's like a Lego blocks that can be reused in multiple machine learning scenarios. Fourth, it can help to make sure that we can onboarding new teams. This normally will take a long time because of the dependencies on other teams to create new environments, new accounts to assign users. So our goal is to templatize the whole infrastructure using the infrastructure as code to onboard new team member easily. Number 5, most important to our customers is secure. It means that you need to working in your own private cloud. Data is not leaking to internet, etc. Number 6, there are many AWS services that allow you to consume hardware only when necessary. So this prevents the customer with bigger servers, big clusters that up and running all the time. It helps to reduce the cost and also reduce the CO2 emission. So overall, the goal is to reduce the cost in people, processing, and technology. So when you try to design the MLOps platform, here's some tenets that we suggest you to follow. Flexibility, which means that you need to make sure the data scientists are able to accommodate any framework such as TensorFlow or PyTorch. Scalability, it makes sure that the data scientists and machine learning engineers are able to scale resources and services on demand. Reproducibility, it means that the data scientists are able to recreate or observe the past experiments, like what the code used, what is the data used, and what is the result. Reusability, it means that the data scientists and machine learning engineers are able to reuse source code and machine learning pipelines, avoiding those inconsistency and which will further on costing more. Consistency is because the MLOps normally consists of multiple environments, and we want to eliminate variance between those environments. Last but not least, the auditability. It enables the data scientists, IT people, legal departments to audit logs, versions, and dependencies of artifacts and data. So let's have a look on which maturity steps you need to follow in order to achieve this. This maturity model is helping customer to setting checkpoints, helping the team to adapt the new way of working. The model defines the necessary capability of MLOps in 4 key phases. The first one is the initial phase. It's basically standardize your experiments. Data scientists that are able to experiment with machine learning workflow, like building, training, deploying your model using SageMaker services. The suggested developing environment is the SageMaker Studio, in which the data scientists are able to experiment and collaborate based on the Studio notebooks. You do experiment to get familiar with those tools. And then you move to the second phase, which is the repeatable phase, where we standardize an automatic workflow. It's from the notebook to automation. This step is to create automatic workflow we call machine learning pipelines. And machine learning pipelines are responsible to pre-processing, train, post-processing, and to move the models into a centralized place that later on can be productionized. After that, you move to the third phase, which is the reliable phase, where you standardize the guardrails, automation of testing, doing monitoring. The goal in this phase is to make sure the created models performs well, and we can move the models into production with a very robust way. It is suggested to build multiple environments here. For example, you have the development environment, staging environment, meaning that is doing the testing simulation on the production environment before it's promoted into the production. Of course, there will be a production environment as well. So the key goal here is to standardize the different testing, monitoring techniques, and work only with CI/CD pipelines across all those multiple environments. After that, you move to the fourth phase, which is the scalable phase, where we do the templatization. After the productionization of the first machine learning solution, you ops foundation to support multiple data scientist team to collaborate and productionize maybe tens or hundreds of machine learning use cases in this phase. So, as what we mentioned earlier, there are 3 pillars of MLOps. It's combined with people, process, and technologies. And let's first talk the first 2 pillars together, the people and processes. There are many personas and roles who contribute to the whole MLOP platform. I won't go into much details here. The slides will be shared afterwards, so you can take a closer look on where your role fits into the big picture. But very briefly, for the advanced analytics team, which in charge of the data lake, ingesting data, ETL pipelines, it's including the data engineer and data owner. And then it is the data scientist team, which have the data scientist and the machine learning engineer, who collaborate to create the production-ready machine learning use case. And then the platform team, they are in charge of, for example, the CI/CD pipelines to build up the infrastructure. They're in charge of the end-to-end security of the infrastructure, or they also are in charge of the standardization of the accounts across the different environments. And we also have the business pillar here. They are using, for example, visualize the dashboard. They are making sure the business KPIs are aligned, the business problem has been solved by the machine learning solutions. And there's, of course, also the machine learning consumer who's using the solution, and it could give the feedback to the product owner. There's one more pillar. It's the risk and the compliance team. Who's in charge of or who's responsible to audit how the different models has been created. For example, what type of data used in order to create those models, what type of artifacts, and if all of them follow exactly the same policy that's standardized by the business, etc. So they are in charge of approve or review the models. And now let's talk about the third pillar, technology. We will cover how you can implement an MLOps platform by using the tools you prefer. So before talking about tools, let's set the stage of the typical machine learning workflow. There are basically 4 stages, and we normally start from preparing the data. We all know that the high quality data preparation is critical to high quality of the model performance. So this step is very important. Once you got the data in good state, it is used to build and train a machine learning model, and you evaluate and turn the model. You experiment with different features, different algorithms, different hyperparameters until you are happy with the model performance. Then you are ready to deploy the model to production. After deploying model for production, it is not done. Governance and monitoring of the model are kept ongoing because we all know that data coming in from the real world will never look exactly like the data used for training the model. So you need to keep on retraining, returning the model, and the new model need to be deployed to remain your prediction accurate. So now let's go through this machine learning workflow with MLOps in mind, and we can start from SageMaker Studio. SageMaker is a fully managed service that enables developers and data scientists to quickly and easily build, train, and deploy your machine learning models at any scale. While SageMaker Studio is one tool from SageMaker, it is an IDE that enables data scientists to have their own space, file system, your own data, your own notebooks, and to be able to implement machine learning tasks. To set up a SageMaker Studio, you need to define a domain, which contains a set of IAM policies and rules that define what the SageMaker Studio can have access to. Then you create a user profile inside of the domain. In this way, each data scientist will have their own user profile, and you can manage which resources you have access to. It is also simple to change the underneath instance, which is the machine you run your machine learning algorithms. From here, you don't need to shut down the server, switch, and start a new server. Instead, you just need a few clicks from drop-down list with instance options, and you will see more details in the lab. We often hear from the data scientists that around 60 to 80% of their time are spent on data preparation, right? And SageMaker Data Wrangler and SageMaker Processing job can make the data preparation step much easier. Data Wrangler is a low-code, no-code tool. It has 300 plus built-in transforms. You don't need to write boilerplate code over and over again. But on the other hand, if you prefer coding, then SageMaker Processing job will process your data with your defined data processing procedure in a Docker container environment. And the container is ephemeral in nature, which means that when the job is done, the container is terminated. You won't pay for the long-running container. So a bit insight into this SageMaker processing. It is a managed container that allows the data scientists to define which instance, which machine learning algorithm running on top. From the left-hand side, you can see the example of how you can create a specific processing job with the SageMaker Python SDK. You can define the type of instance, the type of containers used to run your code, and in the running processing job, you can also define the input and output paths of the data. By running this piece of code, what SageMaker will do is to get the data from S3 bucket, which is the storage service. You move the data from the storage service to the container storage, and it will be execute the processing job and return the results back to the S3 bucket. SageMaker support predefined container. For example, the container with sklearn library already deployed inside. It also supports managed cluster, where you can create, for example, PySpark processing job and run your PySpark code. This is useful when you have large amount of data. SageMaker also support many key frameworks that you need. If, for example, you are an expert user, you want to bring your own container, you have the option to do that as well. What you need to do is to move your container into the Elastic Container Registry, which is a container repository. And from there, you are able to use your own container from SageMaker. So let's say that you are satisfied with your data now. It's a good idea to store your featured data into a centralized place. SageMaker Feature Store is one of the options. It's a repository for your processed features. It can be shared with multiple teams, so you don't need to process the data again from scratch. And you can consider this as a single point of truth for your processor data. You further split your data into like training, validation, test data, and store it into the S3 bucket separately. And you can also store your data processing code inside of the SageMaker Studio. After the data preparation, you can start building and training the machine learning model and test and evaluate your model, right? Here you can use a SageMaker training job to train the model and use this processing job to, use the SageMaker processing job to evaluate the mode. And the SageMaker experiment here can be used to track each individual execution. You can further store your model artifacts for all the experiment into S3 bucket, and you store the training code in SageMaker storage. So it's very important to have a single place to store all those artifacts for reuse later on in other case. So a bit more on the SageMaker experiment. We know that the machine learning is an iterative process, right? You have to do experiment to observe the impact of incremental change on your model accuracy. And SageMaker experiment is a centralized place to store different metrics from all different execution you've conducted. For example, training or processing, etc. And you can also create visualization dashboard to help you to analyze the results. And experiments, they contain multiple runs, and each of the run will present an individual iteration. You can also log parameters and artifacts for each run. It's up to you to how you configure that. So when you are happy, for example, when you are happy and choose one of the best model, and you can register the model into a centralized place called SageMaker Model Registry. Is a single point of truth of your models. And then the models from the model registry can be shared with other teams, or it can be deployed into another environment. A bit more on SageMaker Model Registry. It's a centralized place to store your model artifacts with version control. It's also specified where in the S3 location it's stored. You are able to store all different object metrics. For example, the performance metrics like mean square error, precision, or recall, etc. It also enables the visibility of who has created the particular model and the status of the model. For example, who has approved this model to go to production. On top of that, it also supports custom metadata. For example, it stores information of your training container, which is useful to use the same container in your development phase to make sure the necessary dependencies are in place. Lastly, from SageMaker Model Registry, you are able to change the status of the model by approve or reject a model to go to production. So you have the control over there. Now we say that you want to deploy the model into the target environments. There are multiple ways to deploy the model with SageMaker. It depends on your application requirements. Here I mentioned two of them. One is the SageMaker endpoint. It is used for low latency real-time prediction, where you can deploy the model use SageMaker hosting services. Another method could be the SageMaker batch transform, where you use it to get prediction for an entire data set. This mode is optimized for high throughput without need of real-time or low latency prediction. And there is no long-running endpoint in this case. So, for example, when the model is deployed, you can further monitor the data drift and model drift is necessary. And we can do it with the SageMaker model monitor, because I mentioned earlier that it's not considering done after you deploy the model, you have to keep on monitoring on it. So Amazon SageMaker model monitoring, it helps you to monitor your data drift from your input data distribution and your model drift. So in terms of the data drift monitoring, you baselining the training data input features. You store the baseline statistics into the model metadata bucket or model registry as a custom metadata. You also baseline the inference data input feature, and you send that to the SageMaker endpoint. So at this stage, both the statistics and inference data baseline statistics are sent to the scheduled SageMaker monitor. It is a processing job where both the training data baseline and the inference data baseline are compared to raise a data drift. 2 points here. Why we need to schedule this job is because we want to have enough inference data. It doesn't make sense to monitoring single data records. Another thing here is that how you decide if it is a data drift or not, it depends on your definition of the threshold in the model monitor. So this is the data-driven, it's a data drift monitoring. So it's also monitored for the model drift. It's a similar path, it's a similar flow. The only difference here is the baselining. For the data drift, we're baselining on the training data input and the inference data input. Well, for the model drift, we're monitoring on both the training input and target and the inference input and predictions. So here, this example is related to you deploy your model into a SageMaker endpoint. You have the other option of doing the monitoring on a batch transform use case. It's also following the same procedure. The only difference here for the batch transform is that you can define the location of your input data, batch prediction output, and training baseline statistics. You decide if you want to monitor before the prediction or after. If it is before the transform, it's monitoring the data drift. If it is after the transform, it is monitoring on the model drift. And then behind the scene, we active the SageMaker monitor to generate the data drift alarm or model drift alarm. And those alarms will then be sent to the data scientist. So far we have gone through the machine learning workflow. In terms of the standardization and automation, we can link each step of the machine learning workflow into a machine learning pipeline, which is with the help from the SageMaker pipeline feature. So SageMaker pipeline is a series of interconnect steps linked and run in sequence. Here you can see a list of specific type of steps. For example, processing could be one of the pipeline steps. Callback steps can be used for call any kinds of other AWS services. And you will see more details in the hands-on labs. And this service is free, meaning that you don't need to pay for the execution of the pipeline. You only pay for the resources used in each individual step. Another benefit of SageMaker Pipeline is that it's well integrated with all different SageMaker components and tools. So here is an example. You have defined a processor, and you bring that as one step into the pipeline on the second box here. And then you linked different steps into a pipeline here. So if we move even further, if we want to standardize and automate even further, we can deploy all the MLOps foundation via SageMaker Project. SageMaker Project contains built-in template so that you can deploy the machine learning workflow with CI/CD tools. You can also further customize on top of the built-in template so that you don't need to start from scratch. The SageMaker pipeline project starts from a code commit, which is a code repository. And here we can see that we have a building pipeline. So it contains the code of processing job and SageMaker pipeline. Every time you push the code to a main branch, it will trigger a CI/CD pipeline to build the SageMaker pipeline. The SageMaker pipeline contains the machine learning workflow steps that you defined, right? In this example, after running the SageMaker pipeline, a new model is created and registered in this model registry. And we can also have a second CI/CD pipeline to deploy the model. It contains the code of how you are going to deploy the model. For example, if you want to deploy it as a SageMaker endpoint or as a batch transfer mode. And here you can also define how to test the model before promoting it into production. So it's triggered from the model registry, going through the event bridge, and is trigger the CI/CD pipeline. You can see that there are many approved steps on the specific model version, and there are also many approval before you promoting the model into production. It's not necessary to use in the example, you can see it's a AWS CI/CD tool, but it's not necessary you are using the AWS native CI/CD tool. You can also have choice to use like GitLab Actions, but the methodology and the whole structure is the same. So in summary, SageMaker Project make the whole process easier with predefined templates. It's using service catalog product running under the hood. With a couple of clicks, the whole infrastructure above are all built up for you. If you want to customize your own project template, you can also do so. You could, based on the predefined templates, customize it for your own scenario instead of creating template from scratch. And this will significantly boost your efficiency. Now, how you can get started. We have some further reference for you to read further. You could also, we also encourage you to get engaged with our training and certificate content today. The Skill Builder, you may already know that, is our online learning center that makes it easier for anyone, no matter if you are beginner or experienced professionals, to build AWS cloud skills. And it's also a suggestion to join the AWS certified community, which we bring together the AWS certified practitioners and builders in an exclusive online community. And you will participate in discussion forums, learning and networking opportunities, and also challenges from AWS teams to earn rewards and recognition. And yeah, please fill in the survey at the end of the session to help us to improve. And now I conclude my presentation. Thank you.
Thank you very much. It was very interesting. I was following the same time when I'm typing, I was following your presentation. And I think the next will be Sophie with her presentation.
Yes.
You can now start sharing.
Yeah.
Yep, I'll just get my screen sharing now. Can you see my slides?
Yes. And I forgot to say that if you have any questions also to our speakers, you can put in chat or in this Q&A section, and we will answer them. Thank you.
Cool. So hello, everyone. My name is Sophie, and today I'm going to be talking about MLOps for health AI. I work as a doctoral researcher at Aalto University, and I'm also the co-founder of a health AI startup called Vermio. And while there's a lot of overlap between my research work and my startup work, in the research side, I do more developing algorithms for health AI, whereas in the startup side, we actually have to build these algorithms into products that are put in front of patients and doctors. And that's going to be the main topic of what I focus on today, because that's where MLOps is particularly important. And so in this talk, I'm going to give an overview of what we do at Vermio and a broad overview of the AI healthcare industry. And I'm going to go into how MLOps facilitates the development of high quality health AI solutions, and then go over a use case from Vermio of developing personalization in digital health apps using multiple types of data sources. So at Vermio, we build digital health apps focusing on women's health. Our goal is to improve women's health outcomes with AI solutions. And our tools are targeted at both patients and healthcare professionals, and also researchers, because there's a big gap in women's health for higher quality health data. And when I talk about women's health, I don't mean just the health conditions that are female specific, like reproductive health. Women's health is also encompassing conditions that are disproportionately affecting women, conditions that affect women differently, like cardiovascular disease, and also gender bias in care delivery. And the reason for why there's a need for better healthcare solutions in women's health, you can look at these statistics as a starting point, which are quite alarming, that early research in cardiovascular disease, for example, mostly focused on men. And as a result today, women are actually 50% more likely than men to be misdiagnosed following a cardiovascular event, and also more likely than men to die from a heart attack. And also women are twice as likely as men to experience adverse side effects from drugs. And so it's clear that basing health solutions on one physiology alone results in suboptimal outcomes. And this is not just a problem for women's health. It draws attention to a broader problem in the use of data in health and medicine, where up until now, the conventional way of running clinical trials, for example, focus on trying to bring a drug to market for a particular group in the population, whereas we need to shift more to a personalized view of medicine, where we take into account an individual patient's unique genetic makeup, their lifestyle choices, and their environment, to be able to personalize medical solutions in a way that benefit each patient optimally. And there's a big opportunity for AI and data-driven technologies here. Medicine and health has always been a data and evidence-based field for the use of clinical trials, for example, to generate evidence that a drug is safe and effective. And so it's no different here in using AI to further improve healthcare. For example, we can integrate more data sources that better represent diverse populations like women. We can develop machine learning methods that explicitly account for the differences in physiology between different groups. And we can move away from this one-size-fits-all approach to medicine to a more personalized approach for the individual patient. And we can also use AI methods to integrate more of our omics data like genomics, proteomics, metabolomics, and so on to improve our solutions. And meanwhile, when we want to try and integrate AI into healthcare to improve patients' outcomes, we also have to think how we're actually going to do that and what value the AI is going to bring to the healthcare system. And this slide shows several ways in which we can integrate AI into the healthcare system. The three main areas being in your resources and capabilities, like for example, for AI for your workforce, or integrated into, say, the machines, like the X-ray machines at a hospital. We can integrate AI into the clinical services, so the actual prevention, diagnosis, and treatments. And this doesn't mean replacing a doctor with AI, but it means more so trying to provide AI assistance to doctors, or maybe integrating AI at the stages of designing the treatments, like using AI to design better clinical trials to make the drugs more safe and effective when they come to market. And AI can also be integrated into post-service activities like insurance billing and at-home care. And AI has to deliver a clear value proposition to justify integrating it into these places in the healthcare system. And those value propositions can come in the form of the direct outcomes, like improving quality of life or reducing the cost of some expensive procedure in healthcare. And AI also has to support improving the broader impacts and consequences for health equity, social welfare, and economic productivity. And when these gains are clear, we can integrate AI into healthcare successfully. And so the opportunities for AI in health and medicine can target different groups or multiple groups in the healthcare system. We have the industry and admin-facing side of healthcare, like the pharmaceutical companies and the insurers. We have the doctors, healthcare professionals themselves, and we also have the patient-facing solutions. And so with solutions that have a stronger capacity to deliver medical intervention comes a greater responsibility and need to generate evidence that these solutions are effective, safe, and there's a need for regulatory oversight. And so these more complex solutions like digital therapeutics that are intended to act in a way that actually deliver a medical intervention also require complying with very strict regulations and guidelines when these solutions are developed. And so moving into what we're doing at Velmio, I want to start with an example of how we use AI in our digital health apps. So this is a clip from one of our apps. And the background here is that this was developed a while ago for the patients who have gestational diabetes, which is a type of diabetes that can develop during pregnancy. And the patient will be given this app to track certain data points during their pregnancy, like, for example, their nutrition. So we can see here in this flow, the patient is logging their nutrition. So they had a cup of coffee today, and the app is giving them some information about the nutrition profile of their coffee, some ingredients analysis for whether this is safe to consume during pregnancy. And then they're also logging some other data points that the doctor has asked them to log, like their weight and their blood glucose, which is an important biomarker for diabetes patients. And then the doctor would receive this information and work out a care plan with their patient and use this information to guide their treatment. And this is quite a short clip from the app. And it may surprise you to learn, or maybe it doesn't surprise us anymore since AI is already integrated into so many aspects of our lives. But there was actually 4 AI models embedded in just that very short clip there. The models range from things from just simple user experience improvements down to actual software as medical device solutions. And so in that clip I showed you, when the person clicked on the screen to log their coffee, there was an option to take a photo of what you were eating, and there's an image recognition model that would analyze your photo and based on that, log the nutrition information. There was also a semantic search AI model embedded into that. So when they were searching for coffee, it would try and come up with useful suggestions like, did you mean a decaffeinated coffee or instant coffee? And there was also a machine learning model when this screen came up with the ingredients analysis, where the app gave some advice based on medical guidelines about whether that is safe to consume during pregnancy or not. And then finally, this wasn't explicitly shown on the screen because we hope that not many patients see this, but when the patient was logging their blood glucose reading, if there's some issue with that, the model detects that there's a high risk of, say, an adverse pregnancy complication from that data, because the app also has the context of the patient's medical history. They would send an alert notification to both the patient and doctor and tell the patient to set up a follow-up appointment to discuss that further with their doctor. So why I want to point out this example is to show that in a single digital health app, we have multiple machine learning models. These range from models that are designed to improve the user experience down to the software as medical device models that try to predict health outcomes or risks of adverse health outcomes. In terms of technical complexity, the models range from off-the-shelf APIs to things that we develop from scratch using techniques that we develop in a research setting. Some of the models were deployed to the mobile device itself, whereas more high-risk models we deploy in cloud environments like AWS so that we can better audit and monitor those models and get on top of any issues that occur more quickly. The models have cover different data modalities, so text, image, time series data, and much more. And also multiple of those models can share common training features in the data set, which is why it's important to have MLOps processes to manage all of this technical complexity. And so there's a clear need that, for MLOps in this situation, because MLOps can provide us with that common set of principles for managing all these stages of the machine learning lifecycle, from our data management to developing, testing, deploying our models, and then monitoring them when they're in the live environments being used by patients and doctors. And also I'd like to point out that during my time in the industry, I've seen that MLOps has been evolving as we better understand the needs of these modern AI systems. In healthcare, we've just barely touched the surface for what is possible with AI in healthcare. And so as more companies across different industries adopt AI, there's a growing need to develop industry-specific practices to make sure that we can manage these AI systems effectively for these specialized industries like healthcare. And so when we think about the machine learning lifecycle, usually people kind of show a diagram that starts from data through to development, experimentation of the model, down to deployment. And in the situation for these software as medical device models, it's actually far more complex than that. For example, the development process alone is broken down into 3 different sections, because in development, we have a lot of quality and safety things to consider, like the regulations for software and medical devices. We also have to consider the effectiveness of the machine learning systems and run relevant clinical studies or pilot studies to confirm that the models perform as they should in the live settings. And we also have to study the usability of these models, because these systems have to operate alongside humans. And so we have to make sure they're fit for purpose, and patients and clinicians accept and trust these solutions and can effectively work with the AI solutions to achieve their goals. And so now I'm going to go through a use case of MLOps in Vimeo apps to personalize health in our mobile apps using multimodal data sources. And by multimodal data, all I mean is just different types of data from different sources. So here in this shot, we can see that a patient is connecting one of their wearable devices to the app. So wearable data is like a constant stream of time series sensor data. And then also if we skip along here, we can see that there are various types of things that patients can log in an app, and this is customized in different products depending on what the specific conditions are, but it can include things like nutrition, symptom logs, even integrating environment APIs as well, so external data that comes from other sources and so on. And then the goal with all this data is to utilize this to tailor the healthcare plans to individual patients. So here we can see that a patient is filling in like a medical questionnaire that was designed by gynecologists and obstetricians for maternity health. And then the app is analyzing the data and interpreting that and giving some risk prediction scores for the risk of adverse events during the patient's pregnancy. And so we want to be able to develop these solutions safely and effectively. And so when we start on a project like this, developing a solution like that, we look at this as a multi-stage process. So in our projects, we always start the project by defining these measurable outcomes for a project, because machines speak in numbers, of course, and so it's important to have quantifiable targets for the intended performance of these systems. And the reason we start here is that it clarifies the problem of what we're trying to solve and the understanding of what the existing solutions are if we're bringing machine learning to this for the first time. It also benefits the customers because it strengthens trust with our clients or stakeholders if we actively involve them in this process right from the beginning. And it makes it easier on the developers because they have very clear targets for developing these systems from the beginning of the project. And of course, this is an iterative process, and sometimes you need to revisit this step and revise your targets if new evidence comes to light during the project. And so what I mean by these measurable outcomes are things like the machine learning evaluation metrics. And here it's important to go beyond the standard accuracy metrics and also consider things like user satisfaction and fairness of the models, for example. So in this shot here, this is a symptom checking module where a patient can write some text about some symptoms they are experiencing, and they'll be asked some follow-up questions to guide them to a solution, to some information, or to connect with their doctor in the app, for example. And it's important in designing this solution that we cover all these different types of factors here. So we have the data quality metrics to ensure the data is valid and detect any potential biases against underrepresented groups. We also want to compare our models with the baseline performance, whatever the existing solution was, if this solution is intended to replace a human who previously did this or some other simple machine learning solution. We want to quantify those so we can ensure that our method is performing better. And we also may have metrics related to regulatory compliance, like the quality management or evidence of the product's effectiveness. And then once this is deployed in the live environment, we then want to monitor the solution for any potential changes or drift in the model's performance. And there may be other business objectives as well. And that's what we would sit down and workshop with our clients and stakeholders in the very first stage of the project to figure out what those are. And once that's been established, we then move into the data management stage. And of course, this is where we bring AWS into the picture because they offer all those cloud computing solutions to be able to manage our data. And so in a Vomeo app, we would have data sources like wearable trackers, symptom logs, questionnaires, nutrition logs, and many other things. And some of these data sources are structured data, so they would go into relational databases. The unstructured data might go in S3 buckets. And more recently, we've been experimenting with this idea of the feature store, where we pre-process our data into this central repository for features, because I was explaining earlier, we have multiple machine learning models in a single app. And so it's really beneficial to have this like one central repository for managing our features. It helps us harmonize the data from all these different sources here. It creates streamlined processes for us for validating the data quality to ensure there's no errors in it. And it also makes it easy for our multiple models to share common features if they're sitting in a single repository. And so once we've done the data processing pipelines, we then move into the development and experiment phase. And here, because we kind of specialize in bringing new techniques from research into practice, we tend to develop our machine learning models from scratch. And so we use tools like PyTorch, for example. And in SageMaker, we can bring those models into SageMaker using a Docker container, which is just a way of wrapping up our code that makes it easy to deploy in the cloud environment. And then we can train a model using SageMaker. And for us, when we look at what type of cloud computing environment we're using for training models, it's really important to have both vertical and horizontal scaling of our computing resources. And what that means is if we want to have a really powerful GPU, we want to be able to access that very quickly and easily. But if we want to have, say, hundreds of GPUs to quickly run an experiment and test some hypothesis, like if we have some hypothesis about what model we think is going to work best in the situation or what set of features, and we need to quickly spin up 100 GPUs to check that, we want to be able to have those computational resources on hand. And so that's why we use SageMaker and run our experiments in this way. And then it's also important for us to track all of these experiments. And so we can log the metrics for each experiment run and quickly review those and analyze them in the dashboard, which makes it really convenient for updating the team or other stakeholders on our progress in developing these models. And in health AI, there's a lot of emphasis on the design of these experiments. We like to design small feasibility studies to validate each of our hypotheses against that criteria that we established back in step 1 when we established the measurable outcomes for the project. And I found it really beneficial in this industry to consider formatting your results in a way that makes use of the kind of established medical experiment designs like case control studies or epidemiological studies. And this just makes it so much easier to communicate these results to medical stakeholders who may not be familiar with machine learning, but they are very familiar with the idea of using evidence to understand a new solution, whether it's a drug or a software-based medical device. And then a technique that I learned from the computer science research world is this idea of ablation studies, where it's very easy, it makes it easy to validate the benefit of every time you introduce some kind of complexity into your model, because often in these situations, business people and medical people question, why do we need to use AI to solve this problem? Is there not a simpler solution? And if you use an ablation study approach, effectively what you're doing is you measure your metrics each time you add some additional complexity into your solution and measure it against your baselines as well to show that there's very clear gains in using these more complex AI solutions versus the alternatives, and makes it much easier to communicate these benefits to all your stakeholders. And then once you've developed a model, we then sit down with all the stakeholders and we review the evidence that were generated. And if everyone is happy with the state of things, we plan to proceed with a pilot study to deploy the machine learning model. Or if not, we go back to the previous step and continue developing. And if we do agree to proceed with the soft launch or pilot study, we then have to consider how we're going to actually deploy this in a live setting. And all these other factors become very important at this point, as they are also typical requirements in medical device regulations like risk management plans, how we're going to validate the performance, not just of the software, but the usability of it and the effectiveness in the clinical setting. And we have to design a pilot study that takes these things into account, test the replicability of any results we got in the training setting, make sure they transfer to the live setting, and also test the usability and how the end users like patients and doctors are interacting with these AI systems. And then we also have to think about the design transfer, like what type of manuals, documentation we need to write for these systems to be maintained, what are the security protocols, maintenance protocols, and so on. And so deployment, we again turn to AWS, and most of the kind of data management and modeling has already been set up by this stage, but then we need to add the parts for the inference. So we could again use SageMaker or other solutions depending on the needs for the deployment to set up an API that can then be integrated into the mobile app. So at Velmio, we work predominantly with mobile and web apps. And so we would create an inference endpoint using SageMaker and then give that to the front-end developers who would integrate that into the app solution. And then we want to consolidate our metrics to monitor not just the machine learning metrics, but also metrics that are coming from the app as well, because we want to know like if there's any issues in the app, like if the app crashed or was some issue like that, we want to consolidate our metrics from both the machine learning solution and the app into one dashboard. And so at this stage, it's important to coordinate with different teams. For example, with the DevOps team, we would handle things like the scalability of the machine learning endpoint, inference endpoint, the APIs for integrating into the app, and any monitoring solutions, CI/CD pipelines, and so on. With our UI UX designers and front-end developers, we would work on the interfaces and make sure they're appropriate for the end users. Like if we need to display any data visualizations, we might do some A/B testing to make sure that these are fit for purpose. And then at this stage, we of course want to set up all the monitoring and make sure that's established once something is being deployed in the live environment to monitor the technical performance, other solution-based metrics and compliance as well in the live setting. And so once we're done, all of these things, we hope that the end result is safe, accurate, and user-friendly machine learning innovation for personalizing healthcare. So I hope that you learned something from this talk and about machine learning use cases in the health AI industry. And yeah, if there's any questions, feel free to let me know.
Thank you very much, Sophie. We have actually one question in our chat. Wait a moment, I can read it loud. So we have this question. Do you have any challenges when data from various sources such as Feedbit, Health App, etc. can be very different and also available in different formats?
Yeah, that's a really good question. That's definitely a large challenge. We started working with wearable data like about 3 years ago, and I think over time the solutions have improved a lot. There's a lot more like off-the-shelf APIs that you can use to consolidate these different data sources. But yeah, back in the beginning, we had to put a lot of work in at the data pre-processing stage to try and format the data in a way to and like test it and validate it to make sure that we could make these different data sources compatible. It's still a challenge sometimes, and sometimes the solution is just you have to kind of focus on the variables that are common across those different wearable products. But yeah, we I guess just put effort in the pre-processing stage of trying to fix up those sorts of issues.
Thank you, Sophie. And I think we now can have 5-minute break and you can stretch your legs and stand because we were sitting like 1 hour. I pause my video for 5 minutes and we will back after 5 minutes. See you. And we will start our lab. So I'll put all information about labs in our chat. Thank you.
One-time password. And you can then enter your email and you will get a one-time code. It will take you to another screen where you put that code. And you will access the event, which has both the instructions for the workshop as well as a link from which you will be able to access the AWS account. We will do that now in the breakout room. So have a thought, where would you like to, are you like more fast-paced or you want to take things easy? And yeah, I think we can meet there. We will have 2 supporters per room so that there is one kind of sort of presenting and the other is more taking questions in the chat or in the Q.
It's nice that two of you can join. And I have one question. How many hours it is available, this account? For example, if someone want to finish all the labs later.
Right. You will see a countdown when you join the event, and we set it for 6 hours. So basically you have 6 hours to run the workshop. Even after we finish, you will be able to continue if you are interested in a notebook that we haven't covered. And keep in mind that this is a complex topic. So some of the notebooks can be quite overwhelming, but we will try to break things apart and explain what is important, what to keep in mind. So basically these notebooks will cover a lot of features. And you don't need necessarily all of these features, right? When you start experimenting and deploying your first models. So it can generate confusion, but we will try to, address that as well.
Yeah, thank you, Miguel. I can now stop my recording. So I just want to thank all speakers and also Miguel, who was in our breakout room and helped with labs. Thank you very much for this workshop, and we are waiting you in October. Yeah, we have the next workshop, large language models. So see you there, and we will send all material to your emails next week. Thank you very much.
Thank you all.
Thank you very much. Really appreciate it.
Thank
See you
you.
next training. Bye.
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 Bye.